Good morning all for this wonderful day. I welcome you all for this ACT Perarna GATE coaching class. Today we are going to learn from computer networks by our resource person Dr. G. Aravind Swaminathan sir. Sir, we welcome you sir for this wonderful session. The session is yours sir. Just start your presentation sir.
So, hello everybody. Very good morning to one and all. I welcome you one and all to this session on computer networks. Today we'll be seeing about the topics such as we'll be seeing about the network layer, and also we'll see about IP addressing. Okay, and also last class we are seeing about the data link layer. If there's some details and regarding the CDMA, CSMA, the carrier sense multiple access collision division. Some topics are left. We'll see about that, and also today we'll see about DHCP, and also we'll see about network address translation, and also today we will see about the gate questions. Okay, we'll see about the gate questions, how the questions have been asked. Okay, so with this introduction, we'll just start the class. And let me share the screen to you. My system is a little bit process taking place. Pardon me, it's getting loaded.
Okay, students, kindly wait for some minutes. Sir is connected due to some network issue. He left from the meeting. Kindly wait, he'll join soon. Can anybody say what we learned in yesterday class, computer networks? What are all the topics we learned from the previous class? Can anybody? You can type your answer in chat box also. You answered well when Sir asked all the questions. I think you all remember the topics also. என்ன டாபிக்லாம் பார்த்துருந்தீங்கம்மா? இளைய சுதீர், சுதர்சன், கவிதா, yes, topology, roles of the layer, and the OSI layers. Okay, thank you. And what are all the protocols which used in all the layers? Everything we learned from the previous day class. Yeah. What is other than OSI layer we learned from the last class? Topology, roles, and OSI layer alone we learned. Yes, network device we learn. No, yes. I think Sir came. We'll hear from Sir's words. Sir?
Sir, we'll start.
Okay, sir. Okay, sir. Okay, sir.
Okay, we'll start with the network layer IP addressing. Okay. Okay, once again, very good morning to all. Sorry for the delay due to network issues. Okay. Okay. So we'll start with the network layer services today, and we know that in the network layer deals with the routing, and also the IP addressing takes place in the network layer. So routing is part of the network layer, and it is done with the help of the device called router. Okay, so we can see here a typical example of how the networking devices are working. Okay, so for example, here we are seeing a typical example. You would have studied, you know, if you're in the final year, you would have studied email transaction, how it is taking place between some sample users like Alice and Bob. Okay, so typically we are having the different layers. We are having the different layers. So the Alice, if she's sending a mail, if she is sitting on top of the application layer, and she is sending the mail, and we are having the physical layer, data link layer, network layer, transport and application layer. This is the bottom up approach. Top down approach, we have the application layer, we have the transport layer, we have the network layer, data link layer, and also the physical layer. This with the respective to the they have given with respect to the TCP/IP protocol suite, where they have omitted the session layer and the presentation layer. Okay, and it is like what the data are being sent, and we have the different routers, and also as we saw that we are having the different internet service providers, and we can have a switched WAN, and also we can have the national ISPs, the internet service providers, and through which the data are reaching. So the important devices which we are having here are the routers. We can have a WAN switch, and also we can have a LAN switch. Okay, and also we can have a point to point for we can have for WAN. Okay, for the wide area network. And it is like we are familiar with the router, and as we saw, we have one router for our college. We have a one router for our college, and we saw that what the cost of the router is high, so will have limited amount of routers. Okay, in a organization, and we can have different switches. We can have n number of switches. For example, as I told, in our lab we are having different. We can have a separate switch through which all the devices are getting connected. All the devices are getting connected. So before going ahead, I wish to ask one question. Like we had discussed about topology, which is the geographical arrangement of the systems. We saw it in the last class. So um, any idea what topology are we following in our lab? What topology are we following in our lab? Any idea what topology we are following in our lab? Any idea what topology are we following in our lab? A hybrid. Okay. So hybrid is it's a combination of different topologies. Okay. Do we have a hybrid topology? Do we have a hybrid topology? Any other guess? Any other answers from anybody? Yeah, we follow a star topology. We follow a star topology where we are having a switch. It acts like it acts like the main hub through which the different with different mediums the what we are getting connected. Different systems are getting connected, and we are able to get the connection. Okay, fine. Yeah, next packetizing. So in the we know that like what we know that this typical question, it can be asked anywhere. It's like what how do we call the data in the different layers? For example, we know that in the we are having we are in the application layer. If we come from the application layer, how can we call the how can we call the data in the application layer? Any idea? So we see that in the context when the data are moving, the application layer, how do we call the data? My question is like in the physical layer, we call it as zeros and ones. Am I right? In the physical layer, we call it as zeros and ones. So how do we call the data in the application layer? Any idea? Any idea? How do we call the data in the application layer? How do you call the data in the application layer? Any idea? Let me give a clue. It starts with letter M. M. It starts with letter M. Any idea? How do we call the data in the application layer? Anybody? It starts with M. Please give me a clue. Please give me an answer. You can please give me a guess. So in the application layer, we call it as messages. We call it as messages. Okay, fine. So how do we call it in the transport layer? How do we call it in the transport layer? Any idea? How do you call it in the transport layer? How do you call it in the transport layer? So in the transport layer, we call it as segments. In the transport layer, we call it as segments. So naturally, how do we call it in the network layer? The network layer we call it as packets. Okay, network layer we call it as packets. Okay, and then in the data link layer we call it as frames. Okay, and in the physical layer we call it as zeros and ones. Let me repeat it once again. So it is like what we in the it is like in the application layer. It is in the form of when we type email. It is in the form of a message. It is the form of message, and when it comes to the transport layer, it is in the form of segments. Okay, and obviously the network layer we call it as packets. Okay, we call it as packets, and in the data link layer we call it as frames, and also in the physical layer we call it as zeros and ones. Okay, so the first duty of the network layer is definitely packetizing. Packetizing is a duty of the network layer, encapsulating the payload in a network layer packet at the source and decapsulating the payload from the network layer packet at the destination. And in other words, one duty of the network layer is to carry a payload. Payload is the data from the source to the destination without changing it or using it. The network layer is doing the service to a carrier, such as the postal office. Just like a postal office, the network layer is doing the delivery from the sender to the receiver or to the source to the destination. Yeah, so we are the main functionality of the network layer, like how we saw is the functionality of routing. Routing is nothing else but it is the choosing of the best path. We select the best path and we are sending the data. And we are also doing the forwarding. So forwarding, the difference between forwarding and routing is like what? Forwarding is just the forwarding of the data takes place. But here, when it comes to routing, intelligence, a level of intelligence is involved. Intelligence is involved. Why intelligence is involved in the sense is like what? The best path has to be chosen. The best path has to be chosen. So if the best path has to be chosen, intelligent decisions has to be done. So if intelligent decisions has to be done, there should be a software that has to be running. Okay. So you have to with the help of a routing protocol, intelligent decisions can be done. Okay, if some intelligent decisions has to be done. So for example, we talked about OSPF in the last class. So when you say OSPF, it is like what? We are having the shortest path first. Okay, we are based on the shortest path, we are making the selections. So and also we are also having the other services that are being done in the network layer. So another one area in the network layer is like what? The packet switching. Okay, with the packet switching. So here it is like what? We are having the packets. Okay, we are having the packets, and based on the ports, and the data are flowing, like how electricity is flowing, same like that, the packets are flowing. So these packets can also be we call this as datagram. We also call this datagram. And normally datagram approach is like what? It is associated with the UDP protocol. It is associated with the UDP protocol. So it is like what we have the datagram approach, and the datagrams are flowing from the source to the destinations. Okay, from the source to the destinations. So we can have the sender, we can have the receiver. So we can have that. We can have the routers. We can have the routers are right in the middle. So and the packets are flowing. And one aspect in the sense is in the packet switch network is like what they can uh, they can go in different directions. The packets, the message is getting the message or the segments, they are broken into different packets, and they are taking different routes. Okay, one of the advantage is that the packets are taking different routes. Okay, and they are going in out of order. Okay, and at the receiver we are the reassembly of the packets are taking place. At the receiver, reassembly of the packet is taking place. So we can have the forwarding table, we have the source address, we have the destination address. Obviously without the source address and the destination address we cannot do anything. And also we can have the interfaces. Okay, we can have the interfaces, and it is reaching the destination. Yeah, any idea what is meant by what is your understanding about an interface in a router? What's your understanding about an interface in a router? So interface is nothing else but it is just like a port, like how we have in a laptop, or like how we have different ports through which we can insert a USB port. Same like that, a router. The router device will have different ports. The router device will also have different ports through which we can connect, and we can assign an IP address through which a network can be connected to the router. So when you say about packet switching, we have to talk about the virtual circuit approach. So here in the virtual circuit approach, um, it is like what after the connection setup, connection is getting set up, and after the connection is getting set up, the datagrams can follow the same path. The datagrams can follow the same path, and we also use a virtual circuit identifier. So here we see that the virtual circuit is getting set up. The circuit is getting set up, and then the packets are flowing, and we see that the difference between um, the difference between the packet switching and the virtual circuit is like here. Uh, there is no reassembly of data, and packets are not taking different routes. The packets are not taking different routes, but they are going in the they are taking the same route, and the same order they are moving. They are moving in the same order. They are moving in the same order, and they are reaching the network. Okay. And we see that it is like what the connection is getting set up, and after that the data is the packets are moving the same direction, and there's no need for reassembly here. And also we are having the ports. Okay, we are having the ports here. Uh, ports are port number is used, and also we have an incoming label, and also we have the outgoing label. So last class we saw about ports. So ports are part of which layer? Any idea? Ports are part of which layer? I asked last class also. Ports are part of which layer? Yeah, very good, very good, very good. So ports are part of transport layer. Like what? Ports are associated with the transport layer. IP address is associated with the network layer, and the physical address is associated with the data link layer. Okay. So the physical addressing is associated with the data link layer. The logical addressing is associated with the network layer, and the port addressing is associated with the transport layer. And we also have another term called socket address. We call it socket address. Any idea what is meant by socket address? I think pre-final years you can have a better idea on network because on networking because you are studying freshly on computer networks. Any idea about what is socket address? Socket addressing. What is socket addressing? Very good, very good. The IP address plus port address. The IP address is IP address plus port addressing is called as the it is called as the is called as the it's called as a socket addressing. For example, if you are doing a Java program, if you are doing a Java program where you have a server and you have a client, okay, and in that point we go for local host. We go for local host. If the both the server and client are running on the same machine, then we call it the IP address is the local host, and also we can have the port numbers. We can also have the port numbers to which we can get connected. Yeah, so this is another depiction of how the virtual circuit takes place from a system A to B. Okay, and we can have the different ports. Yeah, we are having here. It is like what we are having router R1. This it has got a port called 1. It has got 2, also 4, and also it has got 3. Also, we can have different labels, and through which the virtual circuit is getting established, and after that the data are moving in the virtual circuit, the path that is set up by the virtual circuit. So also we can have an acknowledgement packet. We can also have an acknowledgement packet once the data receives in the uh, we receive back the acknowledgement. Fine. Next, let us move to the very important topic called as the network layer performance. In the network layer, also we got the performance of the network layer. Yeah. So yesterday I asked about this question. Also I asked. I wish to reiterate this question. This performance of the network. In other words, how can we call it? Performance of the network. How can we call it in other words? Performance of the network. How can we call it in other words? Is there any other word for, or is there any other technical word we use for measuring the performance of a network? Yeah, we call this the quality of service. The quality of service. So as we discussed in the last class, in the quality of service, it is like what the in the quality of service, the bandwidth has to be high, okay, and the throughput has to be high, okay, and so because bandwidth and throughput are related to the speed of the network, and we are having the delay, and also we are having the we are having the delay, and also we are having issues like there's another point called jitter, and also we got reliability, okay, and fault tolerance, or in other words, you can call this reliability. So when you say the performance of the network or the quality of the service, so the aspects like bandwidth has to be high, throughput has to be high, okay, and delay has to be less, okay, and reliability of the network should be more. And when you say reliability of the network, it is like what it has the network should be fault tolerant. Even there is a issue, or if there's a error, it should be still able to perform. That is basically called as fault tolerant. Okay, and in this context, there is another word called jitter. I don't know how many of you have come across. Yeah, so can you define what is basically called as jitter? Jitter. Yeah, delay. So what's the difference between delay and jitter? What's the difference between What's the difference between delay and jitter? Because jitter is also delay. Let me type the spelling. What is the jitter? Variation in delay. Okay, fine. So, thank you for that answer, Shivani. So, delay is called as jitter is called as allowable delay. So, allowable delay. So, to some extent, delay can be allowed. Okay. For example, this morning when I was just loading the my laptop, now it is like what when I was just simultaneously opening all the PowerPoints. Now it was not able to. There was a delay, and my laptop was not able to respond. Okay. So this basically what the what system getting delayed, and it is like what to some extent a delay can be allowed. This delay is basically called as jitter. It is basically called as jitter. Fine. So here we see that uh, the upper layer protocols they use the service of the network layer expect to receive an ideal service, but the network layer is not perfect. We cannot expect every system or service to be ideal. Ideal is something like what you don't have any issues. You don't have any issues. That is basically called as the ideal situation. But you cannot expect an ideal situation. There can be always there can be delays. There can always be delays. So in that context, in that context, we are having we are facing delays. Okay, and also we can also face packet loss. We can also face packet loss. Okay, so this performance of the network can be measured in terms of delay, throughput, and packet loss. Okay, and congestion control is an issue that can improve the performance. Okay, fine. Okay. So when you talk about when you talk about delay has to be less. Throughput. So what do you mean by throughput? What do you mean by throughput? How do you differentiate the throughput and bandwidth? So it's like bandwidth is basically the data rate. Bandwidth is basically the data rate. We denote in megabits per second. We denote in megabits per second or kilobits per second. So, for example, if you are having a fiber optics connection at our home, so the bandwidth is 100 megabits per second. Okay. So throughput is something like at a particular situation, the data flow can be 80 megabits per second or 75 megabits per second, or it can be 90 megabits per second. So it is basically at that point how much data is flowing. Okay, so it is like what throughput can be defined as the ratio between the input we are giving and the output we are getting. Input we are giving and the output we are getting. That is basically called as the throughput. Okay, so it is also denoted in megabits per second. Both throughput and also the bandwidth they are expressed uh, in what in bits per second. In bits per second, it can be megabits per second or kilobits per second. Okay, fine. So and sometimes there can also be packet loss. So packet loss has to be reduced. Packet loss has to be reduced. Okay, fine. So there is also another one aspect called congestion control. Okay, congestion. So congestion control is part of which layer? Any idea? Congestion control is part of this layer. Congestion control is part of this layer. Anybody? Congestion control is part of this layer. Congestion control is part of this layer. Anybody? Congestion control. Very good. Congestion control is part of the transport layer. So we have like how we have the flow control, error control in the data link layer. Same like that, we have the flow control and also the error control that is taking place again in the transport layer. Again, it also takes place in the transport layer. So congestion is like what? Congestion is like the it is like it is a as a situation like in real life how we say traffic jam, how we say traffic jam. So the packets are they are stuck up between the source and the destination. Because they are stuck up between the source and the destination. They are not able to able to reach the destination, but because of traffic jam, they are stuck up between the source and the destination, and there is what there is loss of packets. There is a loss of packets. They are neither with the source nor with the destination, and they are getting they are getting lost in the path, and that is basically called as packet loss. Okay, so when there is congestion, so the congestion will lead to affect the network performance, or it will not affect the network performance. Congestion. So when there is congestion, there is like what? The performance of the network will not be good. When the performance of the network will not be good. So we have to control the congestion. We have to control the congestion. So controlling the congestion will increase the performance of the network. Controlling the congestion will increase the performance of the network. So yeah, uh, data link layer also, we are having the data link layer also. We are controlling this traffic jam, the Ethernet. So how do we call that? How do you call that? The data link layer also. We have a similar situation like congestion. So how do we call that situation? We call it as collision. We call it as collision. So for that purpose only, we go for CSMA, carry sense multiple access collision direction. We go for carry sense multiple access collision avoidance. If there is time today, we'll also see that also. We'll see that also today. Okay. So we go for in the data link layer, we deal with carry sense multiple access collision direction, collision avoidance. In this way, we deal with the collision. In the when it comes to transport layer, we go for congestion controls. We go for many congestion control algorithms. We have algorithms like one of the very important algorithm for congestion control. Can anybody tell me in an algorithm for congestion control? Anybody remember? There's an algorithm called back pressure algorithm. There's an algorithm called very good, very good. There's something leaky bucket is there, and also we have an algorithm called back pressure. We have algorithm called back pressure algorithm, and we can also have choke packet. We can also have choke packet. So choke packets can be sent back to the source, and with the help of the choke packet, the flow of the data can be controlled. The flow of the data can be controlled. The flow of the data can be controlled. Okay. So normally we call this situation as overwhelmed. We call this situation as overwhelmed. Overwhelmed is like what? The source is sending it is sending the packets to the destination, and then we have a sender, we have a receiver, and the packets are being sent. The receiver is receiving the packets, and in one point of time, it is not able to receive the packets, but still the packets are being sent. So that this situation is called as overwhelmed. Overwhelmed. So, and in this point, there is it leads to packet loss. Packet loss. So packet loss has to be controlled, and also congestion also has to be controlled. And this two aspect can give a good performance. It can give good performance. So we can have delay. Delay, when it comes to delay, we can have between the source and the destination. The delays can be of four types. We have the transmission delay, propagation delay, processing delay, and also queuing delay. Okay, so these are the different kinds of delay: transmission delay, propagation delay, processing delay and also queuing delay. Okay, and we are having the throughput. So at any point in the network, okay, the number of bits passing through the point in a second. So which is basically called as the transmission rate. So transmission rate at that point. So this is basically it is called as the throughput. Okay, this is basically called as throughput. Okay. So we can this throughput and also this bandwidth. It can be taken like taken as like how water is flowing through a pipe, like how water is flowing through a pipe, and how much amount of water is flowing through the through that pipe. Okay, so that is basically called as it can be called as bandwidth, and at that point of time, how much is getting uh, how much amount of data is getting flowing. Okay, in a second. Okay, we can call it as the it's as a transmission rate, which is the throughput. Okay, so we see here we have the source, we have the destination. In between, we have the routers. Okay, and it can be we can have the transmission rate. So it can be in the form of kilobits per second, or it can be in the form of megabits per second. So here we see that the transmission rate in link one is 200 kilobits per second, link two is 100 kilobits per second, and it can be 150 kilobits per second. So it also depends upon the links. Sometimes the link can be optical fiber, the link can be wireless. Okay, it can be wireless, or it can be a link that it can be coaxial cable. It can be coaxial cable. So we are having the transmission rate. We are having the transmission rate. So we have a backbone with a very high transmission rate. So backbone is a backbone network. The backbone network we call it as a backbone and network, and TR we call it as the transmission rate. Normally, this backbone we call it as the internet backbone. We call it as the internet backbone. Fine. So we can see here effect of the throughput in shared links. We can have R1 and R2, which are the routers, and we can have the main link, and we can have the transmission rate. We can have the transmission rate. It can be measured for the main link. Next, we see about what is packet loss. Okay, packet loss. Okay, normally packet loss takes place when there is uh, packet loss takes place when there is congestion taking place. When there is a congestion takes place, as I told, we have a sender and a destination, and when you are not able to reach the destination at the time, when you're not able, then the due as a just like a traffic jam, the packet is neither with the sender nor with the receiver, but it is getting lost on the path. It is lost on the way. That is basically called as the packet loss. Another issue that severely affects the performance of communication is the number of packets lost during the transmission. So packets are lost during the transmission. So this is basically called as the packet loss. When a router receives a packet while processing another packet, the received packet needs to be stored in the input buffer, waiting for its turn. Router, however, has an input buffer, the limited size. A time may come when the buffer is full and the next packet needs to be dropped. Okay, sometimes there's a situation that the buffers are full. Okay, so in that case, the packets has to be dropped. So the effect of packet loss in the internet layer is that the packet needs to be resent. In turn, may create overflow. So sometimes the overflowing of the buffer take place, and it leads to packet loss. So we are having congestion control is taking place at the transport layer. Okay, and it is like what we have the this congestion at the network layer is related to two issues: throughput and the delay. The throughput and the delay, and we see about this how we can control the congestions. Okay, so the effect of the congestions is shown here. Okay. So obviously, you can understand that when there is a congestion, the performance of the network is like what? Fails. The performance of the network fails. So we can see here the capacity. There is when there is no congestion, there's no congestion. It is like what the performance of the network is also good. Okay, the performance of the network is good. Fine. And when there is we can you can see here this picture, so that here when there is no congestion, there is what the throughput increases. The throughput increases, and when there is congestion, the throughput decreases. Okay. So you have to understand this important point. So congestion increases. At the end of this at the end of this session, we'll see the gate questions. At the end of this topic, congestion increases. So when the congestion increases, the throughput will increase or decrease. Congestion increases, throughput decreases. Okay. So, and when congestion decreases, throughput decreases. Congestion decreases, throughput increases. Okay. So yeah, this one of the algorithm is the back pressure algorithm. Back pressure algorithm is the algorithm that is used for dealing with congestion. So it is like what we intimate the source to send the to restrict the flow of the packets to the destination. Okay, that is basically the back pressure algorithm. And also we are having the choke packet. We are having the choke packet, and using the choke packets, we are able to control the flow of the data. Fine. Yeah, fine. Next, we'll see about IP version 4 addresses. Before we see IP version addresses, we'll see some of the gate questions. Okay. Let me share the gate question slides to you. Are you able to see the slides? Are you able to see the gate questions?
Hi, sir.
Fine. So we'll see here. Um, Consider the following statements about the functionality of an IP-based router. A router does not modify the IP packets during forwarding. It is not necessary for a router to implement any routing protocol. A router should reassemble IP fragments if the MTU of the outgoing packet, the outgoing link is larger than the size of the incoming packet. So which of the following statements is true? So it is like what the answers can look very similar. Okay. So we can see here that it is like what it's like what we see here that it is like it is not necessary for router to implement any routing protocol. Okay, so it is like what routing protocols can be implemented, but without routing protocols also the forwarding of the data takes place. Okay. So the false answers, it is like what? A router should reassemble IP fragments if the MT of the outgoing link is larger than the size of the incoming packet. Router does not modify the IP packets during the forwarding. Okay. So it is like what? The, the IP packets are also, it is like what? During the while forwarding, it is like what? The details are also added. The headers, trailers, and also port address. All those details are also getting added during forwarding. Okay. Okay, fine. So fine. Next, we will see about uh, regarding the time to live. Okay, time to live. So one of the header fields in IP datagram is the time to live field. Which of the following statements best explains the need for this field? Okay, time to live. Um, it is time to live. You have seen time to live also in the in the also regarding while we used the ping command also. While we use ping command also, we would have also dealt with the time to live. Okay. So what's the need for time to live? Okay. It can be used to prioritize packets. It can use to reduce delays. It can use to optimize throughput. And used to prevent packet looping. We go for time to live. Any idea? One of the header fields in IP datagram is the time to live field. You can think and you can tell me the answer. What's the need for time to live? I think can tell me. Any idea? Oh, you're not able to find the PPT. I'm sorry. I trust you are able to. I trust you are able to see it now. Okay. Time to live. Okay. So TTL field. Okay. What's the what's the need for time to live? It is that if we want to prioritizing the packets, we go for time to live, or for reducing the delays, we go for time to live, or for optimizing the throughput, we go for time to live, or we go for prevent packet looping, we go for time to live. Okay, fine. Isai says it is to prevent packet looping. Any other answers we have? Have you come across this time to live packet? Have you come across this packet called time to live packet? Have you seen it? Yeah, 1 minute, 1 minute. am presenting my entire screen. Yeah, are you able to see my command prompt? Are you able to see my command prompt? Are you able to see my command prompt? So yesterday we saw about some of the some commands I just told. Okay. Um, so yeah. So for example, in order to find the IP address of the machine, we go for IP config. Okay, IP config. Okay. Then for finding the MAC address, we go for IP config space slash all. Then in that connection, I told about a command called ping command. Ping command. Okay. So ping command is part of which protocol? Ping command is part of which protocol? I don't want only the people who have answered alone to answer. Yogesh or Isai Selvam. I want all of you to respond. Ping protocol is is part of which protocol? ICMP. ICMP stands for what? ICMP stands for ICMP stands for Internet Control Message Protocol. Okay, so you can see here. So, for example, we see here IP config. So it is like what we are able to see my IP address, and also I am able to see that the default gateway. What do you mean by default gateway? What do you mean by default gateway? What do you mean by default gateway? What is meant by default gateway? Okay, router. Okay. Yeah, I find only the pre-finalists responding. What happened to the finalists? What's the issue? Okay, I want you also to respond. Okay, fine. So default gateway is the what? Is the IP address of the router. Okay, fine. So we can use this command called ping command. I hope you are able to see my command prompt. I trust my entire screen is getting shared. Okay. So I am just checking my connectivity with the router. So normally, if only if my connection is there with the router, I'll be able to get an internet connectivity. Okay. So obviously, I'm working with the internet. So I am just giving ping 192.168.1.1. Okay. So you can see here reply from. So I am getting a reply from the router. Okay. It's equal to 32. Time is equal to 5 milliseconds. There is a time TTL. There is a time to live. Okay. There is a time to live. So it is like the packet send is 4, receive is equal to 4. Okay. So we are able to find that there's a connectivity established. Okay. Fine. Coming back to the question. Okay. Fine. So the answer is like You can see that. Are you able to see the screen? Are you able to see the questions and answers? So the answer is it is used to prevent packet looping. Okay. So looping is a very uh, looping is a very critical situation. So it should not be. We have to avoid that. We have to avoid that. So in that case, okay, TTL is used to prevent packet looping. Okay. Of course, all these things are important. Prioritizing packets, reducing delays, optimizing throughputs, everything is there. But the most important thing is like time to live field is used for preventing packet looping. Okay. Okay, fine. So in this context, I just wish to ask one question to you. Fine. Okay. Yeah. Yesterday, for connecting local area networks, so what's the device we are using? For connecting local area device, what's the device we are using? For connecting local area network, which device are we using? For connecting, see, please listen to my questions carefully. Okay. So for connecting the local area network, we are using the bridges. Okay. Particularly, we are using the bridges. Okay. Router is like what? Router is, of course, we are using uh, we are using the local area networks. It is for example, it's not that router is used only for local area network. It is used for router is the whole world is connected only with the help of routers. Okay, but when it comes to local area networks, one of a device that is used to connect local area network is the bridges. Okay, bridges. Okay, fine. So yesterday we had a question. Why I'm asking this question is like yesterday we discussed about one question. I just I wish to ask this question once again. I just want to revise it. Okay. So what is the algorithm we use in the bridges to avoid loops? I think I am putting the question in a very different form, but we discussed this question. I hope you remember. Yesterday we had a question. We discussed the gate question. This is a gate question. So in that context, I am asking this question: what's the algorithm we are using? Very good, very good, very good. Superb, superb, awesome. I am happy that Hema Blessy has listened very carefully. So we are using the spanning tree algorithm. Okay, we are using the spanning tree algorithm to avoid the loops. Okay, we are avoiding the loops. So loops are very critical situations. So why I'm asking is like, so here also it is like what TTL is used for, time to live is used for packet looping. Okay, fine. Okay, fine. Fine. Okay, fine. I hope you are able to see the next question. For which one of the following reasons does Internet Protocol use the time to live protocol? Okay, fine. This is also the similar question. This is also a similar question, similar answer. Ensure packets reach destination within that time. Discard packets that reach later that time, and prevent packets from looping indefinitely. Limit the time for which a packet gets queued in intermediate routers. Fine. What's the answer? What's the answer? Okay, see, very good, very good. Gandhi has answered. So this answer preventing the packets from looping indefinitely. Okay, fine. Okay, we'll move to the next question. Yeah, I think this question we discussed last class also. So it is possible to have a it is which of the following is false about internet protocol. So yeah, in this context, even Isai had asked me a question. Okay, so multiple addresses maybe I when I went through, there are multiple addresses that context that is system can have a local address and also a global address. A system can in IP addressing, we are talking about local address and global address. Okay, so in network address translation, a system can have a local address, and also when it comes to global, it can have a different address. Okay, so in that context, they have given. So the system, it is possible for a computer to have multiple IP addresses. Which are the things are we discussed this question last class also. Okay, so the addresses, the answers that are true is like it is possible for computer to have multiple IP addresses. So it is like it can have a local address, it can have a global address. If packets from the source to the same destination can take different routes in the network, obviously the packets can take different routes in the network. IP ensures that packet is discarded if it is unable to reach the destination within a given number of hops. Okay, packets are getting discarded. We saw that packets are lost. Okay, the answer is fault is packet source cannot see the route of an outgoing packet. The route is determined only by the routing tables in the router on the way. It's not on the way; it is predetermined. We discussed about this question in the last class. So we'll see one more question. Then we'll go for IP version 4 addressing. Okay. Yeah, I think this question also we discussed in the last class. Okay, fine. So, what's the answer for this one? What's the answer for this one? Which one of the following is true about the interior gateway routing protocols, routing information protocol, and open shortest path first? RIP uses distance vector routing, OSPF uses link state routing. OSPF uses distance vector routing, and RIP uses link state routing. Both RIP and OSPF uses link state routing. RIP and OSPF uses the distance vector routing. What's the answer? Yeah, fine. Last class we saw it is what? RIP uses distance vector routing and OSPF uses link state routing. Okay, fine. So let's see some of the points regarding IP version 4. Okay, we'll see regarding IP version 4, and then we'll continue. We'll see IP version 4, and after that we will we'll see some gate questions. Complete IP version 4 addressing, and then yeah, are you able to see IP version 4 addresses? Are you able to see IP version 4 addresses slide?
No, sir.
Right. So the identifier used in IP layer of the TCP/IP protocol suite to identify the connection of each device to internet is called the internet address or IP address. So an IP version 4 address is a 32-bit addresses that uniquely and universally defines the connection of a host or router to the internet. So we know that IP address is the important one. So the IP address is like what? It is the 32-bit. Okay, it is a 32-bit. IP address is the address of the connection, and not the host of the uh, router on the router. Okay. So we can protocol is like IP version 4 that defines address as an address space. The address space is the total number of addresses used by the protocol. So IP version 4 has got an address space. It can has address space. Protocol uses bits to define address. So the address it's like what IP version 4 uses 32-bit addresses and it can accommodate more than 4 billion. It can accommodate more than 4 billion. Can you please tell me why we went from IP version 4 to IP version 6? Can you please tell why we go from IP version 4 to IP version 6? Okay, security is one of the important issue. Fine. Anything else? Security. Security. Very good. Flexibility. Fine. Flexibility. Anything else? Reliability. Okay. Fine. Anything else? Anything else? One of the most important point for which we just the transition takes place from IP version 4 to IP version 6 is like uh, it is like we know that what the number of devices that is being used is getting increased day by day. And the number of networking devices that is being used is getting increases day by day. So we have to assign IP addresses. Okay, so 4 billion IP addresses is not adequate. 4 billion 4 billion addresses IP addresses is not adequate. So we need more address. We need a more address space. We need a more address space. So since we need more address space, we go for IP version 6. We go for IP version 6. Okay. This is one of the important point. So this is a 32-bit, and we can represent our IP address in both in the binary form and also in a hexadecimal form. Okay. So this 32 bits in 32 bits it is like what we are having we are having we are having uh, we are having the network. We have prefix and suffix. Okay, so it is 32 bits, and we are seeing that we are having classful addressing. We are having classful addressing due to studied in network. So we have class A, class B, class C, and class D. Class A, class B, and class C and class D. This is basically called as classful addressing. We have classful addressing and also classless interdomain routing. We call it CADR, classless interdomain routing. In classful addressing, we are having we divide into class A, class B, class C, and class D. So this is a very important slide. This is a very important slide. Okay, so we are having class A. Class A, it's like what we have prefix and suffix. And class B also we have prefix and suffix. Class C also we have prefix and suffix. Class D it is given for multicast addresses, and class C it is reserved for future use. It is reserved for future use. Okay. So we see here class A. Okay, here it is like what first 8 bits. The first 8 bits. It is given as prefix. It is given as prefix. The remaining part is given as suffix. Class B, here it is the 16 bits are given as what prefix, and the remaining 16 are given as suffix. Okay. Here it is like what we are having the first 3 8 bits as the prefix and the last 8 bits as suffix. And class D is allocated for multicast address, and class E for reserved for future use. It is reserved for future use. So class A, we are having the first byte is from we got it from 0 to 127. 0 to 127 is the class A, and class B it is like what 128 to 191. 128 to 191 is class B, and class C is 192 to 223 is class C, and we have class D it is 224 to 239. 224 to 239 is called as what class D, and Class C, it is what? It is reserved for future use. So 80%, 50% of the addresses are Class A, 25% are Class B, and another 12.5% are Class C. And for multicast addressing, we are using 6.25 percentage, and also for remaining E is for reserved for future use. So altogether, we are using, as we saw, we are using in it's like what it is accommodating up to 4 billion. Okay, 4 billion addresses are being accommodated in the class A. I'm sorry, in IP version 4. IP version 4. Yeah. This next we have classless addressing. So with the growth of internet, it was clear that a larger address space was needed as a long-term solution. The larger address space, however, requests. Now this was what I was talking about. This was what I was talking about. So because of the need for larger address space, the transition takes place from IP version 4 to IP version 6. Okay. So the larger address space, however, requires that the length of IP address also be increased, which means that the format of the IP packets needs to be changed. Although the long chain solutions has already been devised, it's called IP version 6. A long-term solution was also devised to use the same address space, but to change the distribution of the addresses to provide a fair share to each organization. The long-term solution still uses IP version. The short-term solution still uses IP version for addresses, but it's called classless addressing. Okay. So we can have the address space block 1, block 2, block I, and we can have CADR, classes interdomain routing, sample rotations 12.24.76.8. Then you can have 23.14.67.92. Okay, fine. Okay. So next we'll see a few gate questions. Then we'll see. We'll come back to the next topic. Okay, we'll discuss this question. So consider the following three statements about link state and distance vector routing protocols on a large network with 500 network nodes and 4,000 links. So it is like what? The computational overhead, S1 is the computational overhead in link state protocols is higher than distance vector protocols. Okay, I think that we discussed this question yesterday also. Okay, we'll discuss it today also. The distance vector protocol avoids persistent routing loops, not a link state uh, protocol. And after the topology is changed, a link state protocol will converge faster than a distance vector protocol. So, which one of the following is correct about S1, S2, and S3? Okay. So, last class we discussed about the different routing protocols. We discussed about different routing protocols. We saw about distance vector routing protocol. Then we saw about link state routing protocol, and also about OSPF. Okay. And we saw that the updation takes place in distance vector routing protocol. How does the updation takes place in distance vector routing protocol? Any idea? We there was a word that was made. There was a word that was used. Anybody remember that? Anybody remember that? The updation that takes place in the distance vector routing protocol is done in a, how is it done? The word that was used is, it starts with letter P. Starts with letter P. Any idea? Updation that takes place in distance vector routing. Updation that takes place in distance vector routing protocol. Any idea? Not performance. That the in distance vector routing, updation is taking place periodically. Okay, it is taking place periodically. But in if you take link state routing protocol, it is taking place in a more dynamic manner. Within for every 30 seconds, for every 30 seconds, it is like what? It is taking place in a very faster manner. So the updation takes place in a very faster manner in the link state routing protocol. Okay. So we say that we say that we see the points that are given as the computational overhead in link state computational overhead in link state protocol is higher than in distance vector router protocols. So only we saw that S1 is true. S1 is true because the computation overhead in link state protocol is true. Okay. And after topology change, a link state will converge faster than a distance vector protocol. Okay. So we can see that for every topological change, there is a updation that is taking place. Okay. So the convergence also takes place in a faster manner in the link state protocol than a distance vector routing protocol. Okay. So the point that is false is like a distance vector protocol avoids persistent routing protocols. The distance vector routing protocols avoid persistence routing loops, but not a link state, but not a link state protocol. So it is like what? Uh, it is like what? The link state routing protocols also. It is what? It is avoiding loops. The link state routing protocols is also avoiding loops with the help of the rapid updation that is taking place. Help of the rapid updation taking place. Okay. So you have to get an idea about the distance vector routing protocol and also about the link state routing protocol. So this is another one. This is a new question, okay, which is related to the application layer. This is related to the application layer, but still we'll take it up. Which of the following protocol pairs can be used to send and retrieve emails in that order? Any idea? Can you respond to this question? This is a new question. This is a new question. Which of the following protocol pairs can be used to send and retrieve emails? That order. IMAP. IMAP, it is like what? SMTP stands for SMTP. We all know SMTP stands for Simple Mail Transfer Protocol. Okay, SMTP. IMAP. Anybody? IMAP stands for what? IMAP stands for. IMAP stands for. Any idea? IMAP stands for. IMAP stands for Internet Mail Access Protocol. Very good. Fine. POP stands for. POP. POP stands for Post Office Protocol. Very good. Fine. Okay. So now we can give the order. Which of the following protocols can be used to send and retrieve emails? Of course, the part is like, yeah, there's another one that is used. Mime is being used. Any idea what is meant by mime? Mime. Any idea what is meant by mime? A long time. It was studied about mime in networks. It was studied about mime in web technology. Maybe if you have done some web Java programming, also servlet programming, also you would have done mime. What is meant by mime? Very good. Multi-purpose internet mail extension. Okay. Right. Multi-purpose internet mail extension. Okay. And now we can give the answer. Of course, all the answers looks as similar. IMAP, SMTP, SMTP, Post Service Protocol, Internet Mail Access Protocol, Post Service Protocol, SMTP, multi-purpose internet mail extensions. So all are related. Okay. So you have to choose the very best answers out of the four. Can you give somebody give the answer? A, B, C, or D? D, C, B. Okay, Isai has given us D. Vaishnavi has given us C. Colin has given us B. Shivani B. Anybody else? Gandhi, any answers? Gandhi has given us B. Very good. I think the answers Shivani and Gandhi has given us correct. So it is what? SMTP because it is the order. The order. Okay. So mainly it's a simple mail transfer protocol. Within that, we are having the post office protocol. So simple mail transfer protocol is responsible for outgoing mail. Okay. And post office protocol is responsible for retrieving the mail. Okay, fine. Fine. Okay. I will take up one more questions. We will take it up. Okay. Consider the following statements. TCP connections are full duplex. TCP has no option for selective acknowledgement. TCP connections are message streams. So the TCP protocol works in the what? TCP protocol. We all know that TCP protocol works in the like as we saw in the introduction in the last class. What we saw that the TCP protocol works in the transport layer. Works in the transport layer. We have the. So what are the protocols that are working in the transport layer? What are the protocols that are working in the transport layer? Tell me the protocols that are working in the transport layer. TCP. Only TCP is working in the transport layer. UDP is working. Fine. That's all. Only two protocols are working. Oh, yeah, very good, very good. Fine. So we have three protocols working in the that are working in the transport layer. One is TCP. Next we have UDP, and also we have the SCTP. Okay. So TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol, and SCTP stands for, any idea? CTP stands for CTP. So SCTP is a new protocol that is that's being used in the transport layer. SCTP stands for, any idea? Anybody? Stream Control Transmission Protocol. Fine. So yeah. So we all know the difference between TCP and UDP. Okay. Fine. So it is like what? TCP is connection oriented. Okay. And UDP is connectionless. TCP has got acknowledgement. TCP has acknowledgement. TCP has acknowledgement. UDP does not have acknowledgement. UDP does not have acknowledgement. Which one is faster? TCP is faster or UDP is faster? Which one is faster? TCP is faster or UDP is faster? Yeah, tell me which one is faster? TCP is faster or UDP is faster? Very simple question. TCP is faster or UDP is faster? UDP is faster. Why UDP is faster? 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 Have you asked a very difficult question? Last data packets in TCP. Yeah, it's like what? There is no acknowledgement. Okay, not no negative acknowledgement. It means like what? There is no acknowledgement. There's a difference between ACK and NACK. ACK means acknowledgement. NACK means negative acknowledgement. So there is no acknowledgement in the UDP. So there's no acknowledgement in the UDP. So we are having the what? We are having since we don't have acknowledgement, UDP is faster. Okay. So yeah, finally, which one is reliable? Which one is reliable? TCP is reliable or UDP is reliable? Yogesh says that UDP is reliable. Say says TCP is reliable. So TCP has got high reliability. Okay, fine. So SCTP is a new protocol. It has got the best features of both TCP and UDP. It has got the best features of TCP and UDP. Like how we have C, C++, and Java. Like Java has got the best features of C and C++. Okay, same like that. SCTP has got the best features of TCP and UDP, Stream Control Transmission Protocol. So then SCTP, the the data are flowing in the form of messages. Okay. So coming back to our question, Yeah. So consider the following statements. TCP connections are full duplex. TCP has no option for selective acknowledgement. TCP connections are message streams. So where do we, in which protocol do we have message streams? In which protocol do we have message streams? Any idea? Which protocol do we have message streams? In which protocol do we have message streams? Which protocol do we have message streams? Whether do we have it in whether do we have it in TCP, UDP, or SCTP? The question itself, there's an answer. In which protocol do we have message streams? Which protocol do we have message streams? Yeah, we have it in SCTP. That is what in stream control. Okay, we call this message. Okay, and also we have the streams of data flowing in SCTP. Okay, SCTP. UDP also we have streams of data flowing. Okay, and but mostly it is like what it is in SCTP. Fine. So TCP has no option for selective acknowledgement. Okay, okay, fine. Uh, Yeah, out of this, which one is the correct? Any answer? Consider the following statements. TCP connections are full duplex. TCP has no option for selective acknowledgement. TCP connections are message streams. You can think and tell me. Yeah, I'll give you 2 minutes time. You can just think and tell me. TCP connections are full duplex. TCP has no option. TCP has no option for selective acknowledgement. TCP connections are message streams. Only first is correct. Only first and third are correct. Only second and third are correct. Only first, second, and third are correct. Can please give the answers. Following Dishant is told as first. Any other answers? Okay, Vaishnavi has told us E. Varun has told us A. Let us see. I think it's quite a complicated, quite a tough question only. Yeah. So Palan has told that only TCP connections are full duplex. Um, only first is correct. Okay. Okay. Vaishnav has told us B. Only first and third are correct. TCP connections are message streams. No, we cannot say TCP connections are message streams. Vaishnavi, because when you say, as I told, message streams means it is related to SCTP, a stream control transmission protocol, and also if you take SCTP, it is a message oriented protocol. The highlight is SCTP is a message oriented protocol, so we cannot say TCP connections are message streams. Okay, fine. So the answer is that you can see that only TCP connections are full duplex. TCP connections are full duplex, and okay. So and also it is like TCP has option for selective acknowledgements. We know that this TCP has option for selective acknowledgement. Okay, fine. So let's come back to DHCP. So we can see here that as IP address as the last slide, we can see that what we can have internet, and it's like what we are having ISP, internet service provider. They provide for we can take it as what this is a BSNL connection internet to ISP. It is it is reaching our college. We can have different blocks in our college. We can have the FX block, APJ block, mechanical block, boys hostel, girls hostel, and this way the connections can be arranged. Okay. Next, we'll see about DHCP. So dynamic host configuration protocol. So after block of addresses are assigned to an organization, the concept of DHCP is that dynamically we can assign the IP addresses. Okay, that is the concept of DHCP, dynamic host configuration protocol. Network administration can manually assign addresses to the individual host or routers. However, address assignment in organization can be done automatically. So for address assignment to be done automatically, we are going for this protocol called dynamic host configuration protocol. So it's an application layer program using the client server paradigm, and it helps the TCP/IP at the network layer. So we can have DHCP message format. We can have options: boot file name, server name. So using the server, we are assigning the IP address. We can have the client hardware address. Okay, we can have gateway IP address. We can have the server IP address, and we can have the client IP address, your IP address, and time elapsed max, and we can header count, header length. All the things can be there as different fields in the DHCP message format. Okay. So DHCP can have DHCP discover, DHCP offer, DHCP request, DHCP decline, DHCP acknowledgement, DHCP negative acknowledgement, DHCP release, and DHCP inform. So it's like the operation of DHCP takes place like this. So we can have a client, we can have a server. So automatically, the concept of dynamic host configuration protocol is like we are not assigning the IP addresses manually. but we are not. We are doing it automatically. We are. I'm sorry. We are not. We are not manually assigning the IP addresses, but we are assigning the IP addresses automatically. Okay. So that's how the DHCP takes place. Okay. So we can have the client IP address. We can have the client is asking for the IP address. We can have a transaction ID, lease time, and obviously we can have the source port, and also the destination port, and also we can have the source address. We see here what the IP address is not assigned here, not assigned here. Okay, and we have the destination address. Okay, and now we see that the server is assigning back the IP address to the client. It is assigning back to the client, and now we can see that it is making a request. Now see, we can see here there's no address assigned, but here it is the address is getting assigned. Okay, and after that we see that what a request is made and also an acknowledgement made. So this can be given in the form of a FSM. FSM stands for finite state machine. Okay, finite state machine. You can have initialization, we can have selection, we can have requesting, then we can have DHCP request can be made. Okay, DHCP acknowledgement can be done. Then we can have rebinding. We can have also DHCP offer, DHCP negative acknowledgement. If the time has expired, then we go for DHCP negative acknowledgement. So next, it is like we have the network address transition. So I talked about private addresses and global addresses. Okay, so we have network address transition routers. Okay, so we can have local address, and also we can have global address. We can have local address, and also we can have a global address. We can have a local address and a global address. And for address translation, we go for negative address translation. Okay. So we have the source address, we have the destination address. So we can have a private network, we can have, and also we can have a private address, and also we can have a external address. We can have a private address, and also we can have a external address. Okay. I think yesterday Isai asked me this question. So it's like what we are seeing that we can have private address, and also we can have external address. Okay. Have the private address, and also we can have a external address. Okay. Isai, got it? Is there in the line? Okay, we can have private address, and we can not have external address. Okay. So forwarding of IP packets are getting forwarded from the source to the destination, and it is taking place in the form of hops. Okay. And we can have the interfaces. We can have the interfaces like M0, M1, and M2, which are nothing but the ports. Okay. M0, M1, M2, and have the network addresses. So we can see an example of a subnet. We can have a subnet here. So the rest of the internet. So this is subnet 1, this is subnet 2, this is subnet 3. We are seeing it here. It's like what we are having 17.12.14.1. Okay. So we can see here it is like what we are having 1, then 2, 3, then 20, 30, and also we are having 31. Okay, and here we are having 17.12.3 in the series of 33, okay, 34, 46, 47 we are having. Here we are having it in the form of 17.12.14.49 and 49, 50, 62, 63. The form of the configuration is taking place in the form of subnetting. This we got the router R1, okay, and we are having the network. We are having a different network. So here it is connected to the rest of the internet, and we are working. Okay. Before seeing to the about the routing, different. We'll next we will see about some points about distance vector routing and link state routing. We'll see a few more gate questions, and then we'll go to the next topic. Yeah, are you able to see the question? Are you able to see the question? So, which one of the following socket API functions converts an unconnected active TCP socket into a passive socket? Which one of the following socket API functions converts an unconnected active TCP socket into a passive socket? Which one of the following socket API functions converts an unconnected active TCP socket into a passive socket? Any idea? So we have what is meant by API? What is meant by API? What is meant by API? Application API. It's not AUI. It is API. What is meant by API? Yeah, of course, application programming interface. Okay. So you have application programming interface for in what? For the socket API. No, for socket programming, the socket programming. So socket programming, it can be done using C, and also it can be done using Java programming. Okay, fine. I think uh, last year final years would have done the programming using Java. Okay, and now also the present third year also we are doing it using Java. Fine. So you have application programming interface for socket programming. Socket programming is nothing else but network programming. So there we have different functions. We have different functions. So this question is about the functions. So we have a function called connect. Okay, we have a function called connect. So what's the other word for function? 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 Respective to application programming interface. Very good, very good. Method. Okay, we either call this function or method. Maybe in Java we call this method. Java we call this methods. Okay, I think maybe uh, in uh, uh, in C++ we call this functions. Okay, fine. Okay, so we have different methods. For example, connect is one method where through which we get the connection established. Bind is like what? When we go for bind is like what? If there you have a server, you have a client, then the connection has to get binded. Binded means it has to get connected. So that is basically called as bind. So binding takes place with the help of any idea. How does the binding takes place? How does the binding takes place? Colin, any idea? How does the binding takes place? Binding takes place. It can be takes place only with the help of the addresses. So which addresses will be useful for the purpose of binding? Which addresses will be used for the purpose of binding? Don't tell me. Very easy. There's nothing very difficult. There's nothing difficult. I think the in my question itself we have the answer. Only IP. Only IP. The IP address. IP address and the port. Very good. I'm glad that Colin has answered. So it is the what binding takes place with the help of the socket address, which is what the IP address and the port address, IP address and the port address. Right. So that is basically binding. And when there is a connection between from a server to a client, the server has to listen. The server has to listen to get the client, and also it has to get accept. It has to accept. Okay. So these are the different functionalities. These are the different functionalities. Okay. So which one of the following socket API function converts an unconnected active TCP socket into a passive socket? Connected TCP socket, connected TCP socket into a passive socket. So this is done using the method. Any idea? This is done using the method. Listen. Okay, listen. Okay. So because using listen only, what happens? Listen is like what? you want to have a passive socket. Passive socket means it has to be what? In a listen mode. It has to be in a listen mode. When you say accept means it is in a active socket. Okay. So we go for the listen mode. Okay. Okay. So this is a very simple question. You can easily take it up. Easily take it up. The transport layer protocols used for real-time multimedia file transfer, DNS and DNS and email respectively are. I want you to give me the answer. TCP, UDP, UDP and TCP. UDP, TCP, TCP and UDP. UDP, TCP, UDP and TCP. Quite very confusing and tricky question. TCP, UDP and TCP and UDP. For multimedia, file transfer, DNS and email respectively are. Can you give the answers? Can you give the answer?
Sir, what strategy to follow for this option, sir, to relate this option?
So it has to be a very good question. Thank you for asking it. So you have to think that it's a very good question which you asked. For example, all the protocols seem to be matched for this answers TCP, UDP, UDP, and TCP. So what you have to match is like which combination of the protocol can match well for multimedia. For multimedia. So multimedia in the sense is like for streaming, for the purpose of streaming. So we have to think that which protocol is best suited for the purpose of real-time multimedia. For real-time multimedia. So in that context, out of this protocol, TCP UDP, okay, TCP UDP, like what? Which protocol do you think that the protocol will be what? Will be best suited for multimedia? Either TCP or UDP? Which protocol do you feel that it is what? Somebody told that somebody gave an answer that for streaming UDP is best suited. I think Poland gave an answer. I think Poland Rishwant. I think it's like what she told. I think she told that UDP can be best suited for multimedia. So in that case, UDP, TCP, and UDP and TCP. Any other answers? So let us think. So it is obviously UDP, TCP, and UDP and TCP. Okay. So it is like the combination of UDP, TCP, and UDP and TCP. It is best suited. Okay. So these are quite tricky questions. So you have to just think about it and which will be suited, and you have to attempt for it. Okay. Is it clear? Is it? Okay, fine. Fine. I didn't get any response from Shivani, Gandhi, and all. Okay, fine. Yeah, let's move to the next question. So this is also a very easy question. I think this question here. Which of the following transport layer protocol is used to support electronic mail?
Sir, option A, sir.
Huh?
Option A.
Option?
A.
Yeah.
SMT.
Okay. Fine. Okay. Fine. But the answer is TCP. Okay. So it is like what? This is a very tricky question. It's a very tricky question. Can you find the answer by yourself? Can you find the answer? Superb, superb.
The conditions giving transport layer protocol.
Transport layer. Okay, very good. Colin has answered. Fine. Okay, okay. So normally, when we see it, which of the following protocols is used to support the electronic mail? Now we will bounce at SMTP because we know that what for sure that SMTP is for electronic mail. But the answer is question. The question is asked in a very tricky manner. And what? It is like what? It is. They have asked which of the following transport layer protocols. Okay, this is also very tricky. No, very tricky. Now, normally when you see electronic mail, we'll just go to SMTP. But they have asked that which of the following transport layer protocol. So we know that transport layer protocols are TCP and UDP are the only transport layer protocol here. So SMTP is working on TCP. SMTP is working on the on the connection with TCP. Okay, so we have to understand this. Okay, right? Is it clear? Okay, fine. One more question. Identify the correct order in which a server process must invoke the function calls accept, bind, listen, and receive according to Unix socket AP APL. No, it's programming language or a programming interface, application programming language. Okay. So we have to find the correct order in which a server process must invoke the functions calls accept, bind, listen, and receive according to Unix. So you should know the order. You should know the order. Which one has to take this? First, the listening, binding. Binding is the what? Yeah, as I told, the binding. These are the different functionalities. These are the different functionalities. Listening is that what? A server will listen to the client. Okay, and binding is it's like what? The connection has to get binded between the server and the client. So as I told, the binding takes place. Binding takes place with the help of what? How does the binding takes place? I just explained just now. No? How does the binding takes place? I will ask a very difficult question. How does the binding takes place? 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 One. Yeah, of course, the binding will take place with the help of the addresses only. Okay. So the binding takes place with the help of which address? Come on, tell me. Binding takes place with the help of which address? Very good. Very good. Super. Yeah. Uh, the binding takes place with the help of IP address and port address. Fine. Wonderful. But I didn't expect this answer. It is like what your answers are. Your answer is correct, but I didn't expect this answer. Can you give me the answer which I expected? I asked a very difficult question. Paulin and Hema Blasi. Have I asked a very difficult question? So the answer is like what? The answer is it's like what? The binding takes place with the help of obviously IP address and the port address. So this IP address and port address together it is called as the socket address. It is called as the socket address. So the binding takes place with the help. The binding here it takes place with the help of the what? The socket address. Fine. Okay. Fine. Any idea? Identify the correct order in which the server process must invoke the function calls accept, bind, listen, and receive according to units. Is it listen, accept, bind, receive, or bind, listen, accept, receive, or bind, accept, listen, receive, or accept, listen, bind, receive? Very good. Isai has told us C. You have to bind, you have to accept, and listen and receive. Fine. Okay, fine. Okay. Any other answer? Any other answers? Any other answers you have? Any other answers you have? Only Isai has tried it. Anybody else? Okay, fine. Let's see the answer. Okay, fine. Okay, okay, fine. Slightly, there's a mistake uh, in the answer. It is like what? So that it is a good thing. Is like what we see that binding first. Binding has to take place. Okay, and yeah. So we know that when you see about answers, all these answers, binding has to take place first. Then we have to see that what you have to next. You have to listen. Next, you have to accept. Then you have to receive. So the order has to be bind. Okay. Then you have to listen. Okay. Then you have to accept and also receive. Okay. We got it. So it has to be bind, listen, accept, and receive. Okay. Fine. Okay. Let us see about. Almost we have come to the end of the session. We'll just see one topic and then we'll go for the summary of the day. Yeah, Isai has got asked a question. What listens to sir? Fine, wonderful. See, for example, it's like uh, I hope in Java programming there is we have a network programming, we do server programming and client programming. Am I right? We do server programming and client programming. We say first when the server is programmed, when the server is program is you compile and run the program, it says that server is ready. Okay, server is ready. And after that, it's like what? Server is ready and the server is listening. Okay, server is listening. And after that, client is getting connected. And client is getting connected, and the what? Client is getting connected, and after that, acceptance like what? We have the connection is getting accepted. After that, the data transfer takes place. Data transfer takes place, and finally, connection is what is teared down, or it is the connection gets closed. So this is how the understanding of how the it takes place. So the server is ready. The client is gonna get connected. Now accept the it is accepted stage. Then the data transfer takes place, and after that the connection is getting on down. Okay, so this is the procedure. Fine. Clear? Is it clear? I hope it is clear. Yeah, we'll quickly see the routing protocols and we'll come to the summary of the day. Okay. So regarding the routing protocol, the routing table can either be static or dynamic. The static table is one with manual entries. Dynamic table is one that is updated automatically when there is a change somewhere in the internet. Okay. So we just discussed about distant vector routing and also about link state routing. Okay. So distant vector routing, the updation takes place periodically, whereas the link state in link state routing, it takes place in a very frequent manner. In a very frequent manner, it takes place. Okay. A routing protocol is a combination of rules and procedures that lets routers in the internet from each other of the changes. Okay. So we have intra and inter-domain routing. We have the distance vector routing and the routing information protocol, okay, which is associated, and we have the link state routing and OSPF. And are you able to see my screen for the routing protocol? Able to see my screen? Able to see my screen for the routing protocols? Okay, fine. So OSPF stands for Open Shortest Path First. Okay, Open Shortest Path First. So we are going for the shortest path. Okay. Then we have path vector routing and border vector routing. So we have the autonomous systems, and we see that we can have different autonomous systems. The different autonomous systems are connected with the help of the routers. The help of the routers. So here we have the popular routing protocols. We have intra-domain and inter-domain. So we have the distance vector routing and link state routing are very popular on inter-domain. For the inter-domain, we have the path vector, which is a border gateway protocol. Okay. So we can see here the distance vector routing tables. We have the A table, we have B, and we have C, we have D and E. Also, we have the A, B, C, D, and E are the different routers. Okay, they are the different routers, and we have the A has got a table. Okay, so and also it has got a cost. From A to A the cost is 0, and A to B the cost is 5, and A to C the cost is 2, and A to D the cost is 3, and A to E the cost is 6. Okay. Yeah, A to E it is 2 plus 4. Okay. So this is how we have the routing table for every router. Okay, for every router. Okay. So this you would have studied, no? You would have studied. Then initialization of the tables in the distance vector routing. So all the direct connections they have given the cost. Okay, indirect they have marked as infinitive from A to E. This is what it is going to C. So we are marked as infinitive. Okay. So the updation takes place in the distance vector routing. Distance vector routing, each node shares its routing table with its immediate neighbors periodically, and when there is a change, distance vector routing, each node shares its routing table. So the sharing of its routing table takes place with the immediate neighbors periodically. So we can see here that sharing and updation takes place periodically when there is a change. And updating the distance vector routing. Okay. So this is how before failure, after failure, the updation and sharing takes place. So this routing information protocol. So we can have the R1, we can have R2, R3, and how the network is getting connected, and the hop count, first count or second count that they have given, and the intermediate network through which we are getting connected. So this the explanation in the concept of routing information protocol. So routing information protocol and distance vector routing are closely associated. Ring state routing is also similar to distance vector routing, but the updation takes place in a very rapid manner. Updation takes place in a very rapid manner in the ring state routing protocol. So we had a couple of questions regarding distance vector routing protocol, RIP and ring state routing protocol. I hope you might be remembering that. So, and also we are using the open shortest path first, and we are using the Dijkstra algorithm. We are using the Dijkstra algorithm for finding the shortest path. For finding the shortest path, we are using the Dijkstra algorithm. Okay. In the ring state routing protocol. So we are the node A, the cost is 0. You want to go to CE, you might be remembering the cost is it was 2 plus 4 6, and we are going through the router C. Others are what, directly connected. Okay, others are directly connected. I hope you might be remembering this values are similar in the context of this diagram. A to E is 6. The A to E value is 6, and we are going through C. That's what they are given. A to E value 6. C. So and again we are using the areas in router. We have the backbone router. We have the backbone networks, and we have types of links: point-to-point, transit, and stub. Okay. And also we have the point-to-point network in the routers, and also we have stub links. And also when it is we are using the OSPF for finding the shortest path. Finding the shortest path, we go for OSPF, and also for that also we can have the destination, we can have the path, we can have, and finally we have the water gateway routing protocol. We have the water gateway routing protocol for connecting the autonomous systems. So this regarding the different routing protocols we're using. So we'll summarize today's which we saw. So we saw this question. Okay, about the functionality of a IP-based router. So we saw that the routing protocol is required, and it is not that what we need a routing protocol, but without a routing protocol also it can work. Okay, this is about the functionality of an IP-based router. Okay. Then we saw about this question. Time to live. We saw about time to live. Okay. So mainly we saw that time to live, TTL. We saw about time to live. Where do you go for time to live? We saw about time to live. TTL stands for time to live. Time to live is for 1 minute, 1 minute, 1 minute. I'm sorry. I hope you are able to see the screen. Okay, fine. We saw about this question called time to live. Where do you go for time to live? 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 Okay, thank you for the answer. For looping of preventing looping. Okay, preventing looping, we go for time to live. Okay, we saw that. Very good. So that's another question also we saw. IP, time to live field, or it is for what? Is for preventing packets from looping. Okay, looping is what? It's it's a very critical situation. If there's a loop, we cannot perform. So also we saw in this context, we saw that we discussed another. What's the? We saw that we are using the bridges for connecting the bridges we are using for connecting the local area networks, and we are using the spanning tree algorithm for preventing loops. Fine. Next, we saw this. We discussed last class also uh, about the IP addresses in the Internet Protocol. We can have multiple IP addresses. Multiple addresses. So you can have a local IP address, and also we can have a global IP address. Okay, and also we saw about IP packets from the same source to the same destination. Same destination can take different routes in the uh, network. Okay. So it is like what IP packets. They are what they are following the same routes. We are seeing this. We are seeing that they are following the same routes. Okay. And one point that is false is that the packet source cannot set the route of an ongoing belt. The route is determined only by the routing tables in the routers on the way. No, it is not. The routes are not determined on the way. It is what predetermined. Okay. And also this question we discussed yesterday also. Today also we discussed. So now, right now we discussed about RIP and distance vector routing. Okay. So RIP uses distance vector routing and OSPF uses link state routing. So we saw this RIP uses distance vector routing and OSPF uses link state routing information protocol and open shortest path first. RIP uses distance vector routing. OSPF uses link state routing. And we discuss about this question. We saw that computational overhead in link state protocol is higher than in distance vector routing protocol. Because why computational overhead in link state protocol is higher? Why computational overhead in link state routing protocol is higher? Why the computational overhead in link state routing protocol is higher? Because the reason is what? The updation takes place in a more frequent manner. Okay. And after topology change, the link state protocol will converge faster than a distance vector protocol. Okay. So it is like what? For every topology change, there is an updation that is taking place. So both we see the distance vector routing protocol and link state routing protocol avoid loops. Okay. So we saw this question. Which of the following protocol pairs can be used to send and retrieve emails? We saw the answer is SMTP and POP3, post office protocol. And also we saw the which consider the following statements. We saw that what TCP is full duplex. Okay. And TCP has option for selective acknowledgement. TCP connections are not message streams. Okay, only SCTP connections are message streams. Okay, stream control transfer protocol. Then we saw that we have listen, we bind. What are the functions in what? In Unix socket, we have it starts with bind, then you have to listen, then you have to accept, then you have to receive. Okay, this is the order in which we are following. And which one of the conversion unconnected active passive socket into a passive? Which one of the following socket API connection? Unconnected active TCP socket into a passive socket. So it is a what? Listen. It is a listen. There's one more question left. We will see. We will take up this question next tomorrow because we will see about TCP in detail. Okay. So this connection, this question, we saw that how for multimedia, which protocol is what is used. So Isai asked like what how it has to be chosen. The best answer has to be chosen, best suitable. So UDP is best suited for multimedia. So UDP and TCP and combination UDP and TCP. Third one. So this is another tricky question. Which of the following transport layer protocols is used to support electronic mail? So it's not that when you see electronic mail, it should not bounce at SMTP because transport layer protocol it has to be TCP. Okay. So these are the questions we have discussed today. So I'm done. So if you have any questions, you can please ask. Okay, we have 10 minutes more.